So now that we have our working clock class, let's use it to overcome this issue here. I just want to review the issue quickly. When I build and run this, we have some spikes in frames. Every 20th frame, oh look, the unit test stuff is happening. I gotta come over here, Control Alt L, right click and set this as my startup project. Control F5. Okay, so we have some spikes in frames that stops our ship from moving. And our ship, even though we're going to have spikes in frames, hopefully we don't have too many or any at all, but we will have spikes, probably. And when we do, we want the ship to move to where it should have been moving, or it should have been had it kept moving through the frame. One other issue that I actually failed to mention, we're going to take this out, Control KC, and go here to the top. Well, here when we start our timer that calls our update function over and over and over and again, right now we're saying, hey, don't waste any time. As soon as one gets done, call another one and call another one and call another one, and just do it as fast as you can. But watch what happens. I took this out, all right? Now watch our ship speed as I build this. Our ship's moving relatively quickly. It's do you like the sound effects? I don't charge extra for that. Watch what happens if I come over here and bump this up to 200 milliseconds. Alright, so one frame every 200 milliseconds, which gives us about 5 frames a second. See how it's pop, 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 pop. First of all, we're seeing long frame rates. I mean, 200 milliseconds per frame is a long frame rate, but also the ship is moving very slowly. That's because we're basing our speed off of how fast the frames can go. So if the frames are going faster, the ship's going to go faster. And if the frames are going slower, the ship's going to go slower. This is a lot like when I was a kid. There was a game I loved to play. It was called Joust, and I played on my parents' 386 computer. And it had this turbo button. When you pushed it, it said 40, and when you took it off, it said 16. And I think that had to do with the megahertz. I'm not quite sure. But when I had the turbo button on, at 40, Joust was unplayable. Everything just went way too fast. But if I took it off and I had it at 16, then the game was playable and it was a fun experience and all that other good jazz. So back then, that particular game, Joust, the programmers of that game based their speed off of how fast the frames were going, right? Which isn't good. We want to base our speed off of the actual time that is passing, not rely on the frame rate itself. So that's the whole reason why we built the clock. And so now we're going to use it in here to get this ship moving at a regular speed, no matter if there's a frame spike or if the frames are going slower or faster. So let's close this, close that. We need to include our clock. Okay, pound include clock. What is it? Timing. That's right. Timing clock.h. And then, where should we put it? We need a clock that we're going to use. Oh, well, we can just drop it here. We've been dropping everything here in this private namespace. Eventually, we're going to get a little better than just dumping things out in global namespace land for this file. But for now, I'll just do it here. Clock. And I believe there was a using. We had to use our using timing clock. Alright. Clock, and then we need to initialize our clock. So we'll do that here in the initialize GL window. Eventually we're going to get this a little bit more professional and have a solid initialize for our entire game. But for now, I'm just going to do the same thing here. Assert clock.initialize. We'll assert that's good. If you remember, our initialize here sets up our timings and things like that. Make sure we're good. And then we need to call shutdown, but we don't really have a good place to call shutdown on our clock. So we could use the destructor, but I'm of the opinion that I like to be in control of what's going on. Destructors are called deterministically, but they're called when objects go out of scope, and we don't always have control of that. So I want to be explicit here. So I'm going to go my GL window. Let's open that. Oh, come on. Let's do a public section public and bool shutdown, and then go back to the CPP file and say our bool my GL window Come on, IntelliSense doesn't want to cooperate. Shut down. And we'll just return clock.shutdown. And eventually we're going to add some other things here, then we got to keep track of what's shutting down. But for now, we'll just say, hey, see if the clock can shut down. Now, you may be thinking, Jamie, do you remember what you did in the shutdown function for clock? Well, let's go look. Click here, F12. Oh, we just returned true. Well, you may be thinking, Jamie, this is this is dumb. Why don't you just forget about having a shutdown, that, or just return true, but probably just forget about a shutdown because this is kind of useless. Well, it's not useless. Now, this is my religion, but it's not useless. We're going to have many things that initialize and many things that shut down. And say, supposedly I wanted to come in here and write some code that I actually forgot to add for the shutdown. Well, if I have the shutdown and I'm calling the shutdown and I'm relying on the shutdown, then I know everything's peachy. I can replace this return true with some conditional expressions that evaluate whether the clock shut down cleanly or not. But more importantly, I have a very crystal clear in my game here. I have a very crystal clear. We need to initialize and we need to shut down. Alright? Now, I'm also doing a little bit of hand waving here because we init glue here, and we also create some resources here with OpenGL and we never clean them up. So not in this video, but very soon we need to clean up after ourselves, and I'm gonna do that. But for now, I'm just clock shutdown. We'll have that, and then if we have a shutdown, we need to be careful or meticulous about calling it. So I'll go to our game here, my GL window. And this is kind of shady too. I think we'll do this very quickly in another video, but we're relying on OpenGL to call our initialize, which actually we should be explicit here and be able to say my GL window dot initialized, not initialize GL, dot initialize. Alright, but we don't have that function yet. But I'm going to be meticulous and actually call that there. And then here I'm going to say int let's see, error code. How about that? Error code gets that, and return error code. But first I'm going to say bool, or actually if not my GL window dot shutdown. If that doesn't shut down properly, then I'm going to error code or equals. We'll just or in a 1 for now. Basically, we want a non-zero value indicating there was a problem. And the reason why I'm using error or equals is maybe application exec returns its own error code, and so I'm going to or in at least a non-zero value here. And so error code is a mix of what application exec returned plus, hey, we detected there was an error ourselves. And right now, if application exec actually returns an integer value that makes sense and I go and mess with the bits like that, then it no longer makes sense when we return it. But the thing I'm really looking for here is there is an error and you need to address it. And if you want to address it, then you need to go look at the log files for the game. Now, we don't have any logging utilities yet. We'll soon add those. But for now, I just want this. I'm treating this like a Boolean, saying, hey, there's a problem. Go look at the log files and go clean up after yourself, or ourselves, I suppose. Let's see if we can get this initialized to do its job. I'm going to go back to my GL window, and right next to shutdown, we'll do a bool initialize. Go to the CPP file for it. And now we have initialize GL. This is called automatically when the window shows and it decides it wants to initialize OpenGL. But we're going to have our own initialize as well now. So my GL, that font's a little small for a video, window, initialize. And then in here, I'm actually going to put our initialize code there. So let's grab clock initialize, put that in here, KF. And then you may think, Jamie, you got that glue in it. Why don't you initialize that glue in there as well? Well, glue, we have to, it just so happens with OpenGL and the way the glue library works, we have to initialize glue when OpenGL is initializing. And that's why this event here, or this hook is here, is Qt is calling up initialize GL. It's set up the GL context, so to say, we go a little further and set up more OpenGL context with our glue in it, and then go on and do some other things. So it may seem a little weird that we have to have two initializes, but one is for the graphics and the other one will be for our other stuff. Whew! Alright. Do we build? Initialize must return a value. Of course it does. Let's do this. Instead of asserting, we'll do bool error. I don't know. How about this? Success gets clock.initialize and return success. Now I could have done, maybe I should have returned clock.initialize the same as I'm doing down here. For now I will. I think we'll be consistent. The reason why I added that other boolean is eventually we're going to add more subsystems, not just clock, but we'll have other things. And if we have a boolean, we can keep track of which ones succeeded and which ones failed. But for now, we'll just go like that. All right, build. Hopefully it builds. Build start. Oh, did you see that? Linker errors. Do you know why? Do you remember? Hopefully you remember. We've been through this a bunch of times. Sandbox game, we never linked to the engine lib. If I remember right, input. Do you see engine lib in here? No. So let's do it. Engine.lib, semicolon, enter, enter, build. What's going to run? I mean, what's going to happen? Oh, it's going to say can't open engine lig. You probably laughed at me when I did that. Lib. Control-Shift-B. Build failed. Cannot open file engine lib. Why not? Well, that's because we haven't set up the linker paths as well. So general, additional library directories, edit. Let's do a new one. Oops, not there. Can I move this up? No. Whatever. Projector up one into engine and into configuration folder. Okay. Build succeeded. Now run. Nope, engine DLL is missing from our computer. Try reinstalling the program to fix this problem. If you remember, we have to have the DLL next to the exe file in order to get this to execute. That, or we can deploy, we can make the DLL folder visible to the entire computer by setting the path environment variable, which we'll probably soon end up doing. But for now, I can copy that by hand, or I can do what we did with the engine tester project. And I believe we did a build event, or no, not a build step. We did a build event, and we put this command in there to copy the engine DLL to our out directory, and that'll work fine. That'll work fine in the sandbox game. I think let's just do that. Copy this command, and then we're going to put that in sandbox game. Eventually, I want to show you how to do this with custom build steps, so we don't have to do the copy. Instead, Visual Studio will detect the change, and with the custom build step, it'll copy it for us. But I think for now, just to start out basic, and it's good to start out basic and then see better ways of doing that. But we want to go into engine, configuration, engine DLL, and copy it to our out directory. It was nice that I could literally copy and paste that command, because we use these environment variables here, I don't know, macros. We use these macros. Project dir is different for sandbox game than it was for engine tester, but it doesn't matter, it changes automatically because we use the macro. Configuration would change, and the out directory definitely changes. The sandbox game builds to a different directory than the engine tester game does, so this changes as well. But because I initially wrote this using the macros, I could literally just copy and paste that and be good. Let's build, run, and our game's working, but we still haven't used the clock. Oh boy, all that setup just to even get the clock class working in our game, but we haven't even used the code, and this video is long enough. So next video, let's actually use the clock code.